Hopefully by going over this worksheet, it will help you better understand the working backwards and things like that when you are taking your learning check and applying the area. So these are the answers. I already put the answer key up, but if you want to check how you get your answers, I'm going to go right in order. If you need to zoom through to check how do you do one of the problems, go for it. So we got an 8-inch by 4-inch rectangular screen at Meyer. So I know that the total area it covers is 32 inches squared. Well, every one of those inches squared has about 4,500 bacteria, because it says 4,500 bacteria per, you can leave it as 1 inch squared. So in order to get the total bacteria, all we take is the area of my shape and multiply it by 4,500, and we will get how many bacteria, which is 144,000 bacteria on that screen. Number 2, a circle has circumference of 43.96. What is its area? Well, I know to find area, I need the pi. Well, I need pi, and I need to multiply it by radius squared. So if I have circumference, I need to use that in order to find the radius. Well, circumference is diameter times pi. Well, we know that the circumference is 43.96. So if I want my diameter, all I need to do is divide by pi, because that's how you undo multiplication. So diameter is 43.96 divided by pi, which is about 13.99. And then to get my radius, I divide that by 2. And when you do that, you get 6.996, which I'm just going to round to 7.0. Now, once we have the radius, all I need to do is plug that into my area formula. Pi times 7 squared is 153.78 centimeters squared. Number 3 was our warm-up today. The same thing. What's the length of the radius? So I know I've got the area of a circle is pi times radius squared. And like I showed you how to undo this today, I know to get 169.26, I take my radius and I square it, and then I multiply by pi, and that gives me 169.26. So that's the original. To undo it, now I need to start off with 169.26. Need to undo multiplying by pi, got to go backwards. And then undoing squares, you square root. So you would square root, and that's going to equal the radius. So when you do that, 169.26 divided by pi and then square root it, we get 7.34 centimeters. For number 4, I have a 12-sided polygon, and I know the area of the 12-sided polygon, and I know that however many sides there are is the same as how many triangles there are. So if I think about this, here's one triangle. If I can find the area of one triangle, then I can work backwards, because I know the side is the same as the base of the triangle, and I know the apothem is the same as the height of the triangle. So I know the area of the whole polygon is 197, but one triangle, I just take 197 and divide it by 12, and that gets me the area for one triangle. So that's 16.42. So I know to get the area of a triangle, it's base times height divided by 2. Well, the base, we said, was the same as the side length. The height is the same as the apothem, and we divide that by 2. So now I just need to undo. So I undo dividing by 2 and multiplying by 4.2. So it'll be 16.42 times 2 divided by 4.2, and that's going to give me A, which is 7.82. So essentially I'm just looking backwards at that triangle, or working to undo one of those triangles. For number 5, I know that AC is 8, BA is 6, and BC is 10. Now because BA and AC are perpendicular, they are the base and the height of the triangle. Now remember, we said we could draw a base and height wherever we wanted to. So I know that another way to draw the base is this right here. So this could be the base, and AD, what we're trying to find, is perpendicular to that, so that could be the height. So I'm looking for a height, and I know the base. Well, the same triangle has a different height and base, but no matter what, the triangle hasn't changed. So I know that if I find the area of this whole thing, then I can work backwards to find the height. So area is base times height divided by 2, which is 24. So that's the area of the triangle. Well, my other base is 10 and my other height is h. So base of 10 times my height, which is AD, divided by 2. So I need to undo divided by 2 and times by 10. So the height is 24 times 2 divided by 10, which is 4.8. That's not the only way that you could do this. You could find angles if you wanted. You could find this angle, and then you could find this side, and then you can find this height using trig if you want. It doesn't matter. It's up to you. Because we know how to find an angle if we know two sides of a right triangle. Seeing as that this is also a right triangle, we would be able to find this side, BD, or actually we wouldn't even need that. We could just do the opposite side over the hypotenuse here. So it's up to you how you want to do it, but you would need to find an angle if you want to use trig first. For number 6, I am just going to look and cut it into two different shapes. This horizontal line breaks it into a rectangle. So that's my first shape. Well, I know that the horizontal length is the differences in my x's. So from 4 to 10, that makes this length 6. My vertical difference is the difference in my y's. And up 2 and down 5 is a total length of 7. So I know the area for this triangle, or I'm sorry, this rectangle, is 6 times 7, which is 42. This shape right here, number 2, is a parallelogram. These sides are parallel, and so are these. So this base is 6. Now remember, your height is perpendicular to the base, and in this case we would not be able to draw the height within the triangle. We would have to do it on the outside, or not within the parallelogram. It'd be on the outside. So from here, this y is 7 and this y is 2. So that makes the height of the parallelogram 5. So my base of the parallelogram is 6, my height is 5, and that's 30. So total is 72. For number 7, when we're finding the area of this triangle, we wouldn't be able to use any of these sides as the base, because if I were to draw the height perpendicular in, I wouldn't be able to find the length, at least not with what you have learned. So this is where we would take and draw a rectangle around it. Your rectangle sides need to be horizontal and vertical. If you don't do that, then there's no point in drawing the triangle or drawing that rectangle. So vertical and horizontal. So it's remember how we drew in right triangles to make define these distances. Well, you're kind of doing the same thing, except now we're going to find the area of these individual triangles out here. Because if we find the area of the whole rectangle, we can subtract the area of these 3 smaller triangles to get the area on the inside, this area right here. What's nice is that because I drew horizontal and vertical lines, these are all right triangles. So the area of the whole rectangle is from here to here. So that's 2 over here and 8 over here. So that's 10. And then up here, it's 2 below because y is -2 and this is 6. So that whole length is 8. So 8 times 10. And then I'm going to subtract the area of the 3 small triangles. So I need the length, the base, and the height for those triangles. And it's just this. So this is triangle 1, 2, 3. So triangle 1, the base is 4, the height is 1, 2, 3, 4, 5, 6. So the area for that first one is 4 times 6 divided by 2. The area for the second triangle, the base is 4 and the height is 8. So 4 times 8 divided by 2. And then triangle number 3, 1, 2, 3, 4. Four times 10 divided by 2. So 80 minus 12 minus 16 minus 20. And that equals 32. So any polygon on the coordinate plane, you can use this method. Make a box around it and then find the area of those triangles and subtract it from the area of the big box. Now remember, shaded regions, we start off with the whole thing and we subtract out the non-shaded parts. Well, I've got a rectangle and I'm going to subtract these 2 parallelograms. So the area of the rectangle is a 13 by 19, or by 9. And I'm going to subtract the 2 parallelograms. So this is the base for one of the parallelograms, and remember, the height is perpendicular distance to here between the bases. So the area of one of those is 9 times 2. But remember, we've got 2 of them. So 13 times 9 is 117. And then 9 times 2 times 2, because there's 2 parallelograms, is 36. So when you subtract those, you get 81 centimeters squared. In this one, we've got an equilateral triangle. Now remember, we can break this into smaller triangles. That's the method we did. That's not the only method to find this. So the area of the regular triangle, subtract the area of the circle. So I know the base of this triangle here is 14. The height is the same as the apothem or apothem. Divide by 2, and then there's going to be 3 of them because there's 3 sides. And then I'm going to subtract the area of the circle, which I know the radius. The radius is the same as the apothem in this case. So you subtract those, 84.84 minus 51.28. And that gives us 33.56 centimeters squared. All right, 2 more. We've got a big circle and we got a little circle on the side. Inside, the little circle is not shaded. So all you do is take the area of the big one and subtract the area of the small circle. So the radius of the big circle is 4. And I'm going to subtract the area of this inner circle, which the radius is 2. Pi times 4 squared minus pi times 2 squared, 37.70 centimeters squared. And last but not least, we have this fun little shape, a bunch of circles. Something that I like to think of, I'm going to kind of ignore the top part because none of the top is shaded. So I'm going to get rid of that. So what I have left is a half a circle. And then I've got some other half circles taken out of it. Well, the big circle I know has, if it's from 5 here to here, the diameter of the small circle is the same as the radius of the big circle. So, and it's only half a circle that I'm looking at because none of this is shaded up here. So the area of the half big circle, and I'm going to subtract the area of the 2 small half circles. So pi times the radius squared, but it's only half a big circle, right? So I'm going to divide by 2. And the 2 small circles, those are halves. Well, 2 halves make a whole, so you can just think of it as, I mean, you could do 2 times the radius squared times pi, but remember it's half a circle, so you got to divide by 2. So 2 divided by 2 is the same as 1 whole 1. So pi times 10 squared divided by 2, 157.08 minus 78.54, 78.54 centimeters squared. Oh, you should probably be able to see that. Alright, so hopefully this will help. I'm going to post this on YouTube.